We are now recording. Let's get the current slide set up. Well, there we go. Okay. And I believe it will start one of these days. Believe I mentioned to you last time, and I don't know for sure if they're still needing some more people, but if any of you are interested in the math team, and some of you are seem like you're pretty sharp in math, even though part of it is calculus based. Let me get your name, please. Trey? Okay. Thought that, but I didn't want to mark you in the wrong place. Okay. The parts of it are calculus based, especially the team competition. But still, as I've been telling the upper level students, even this will help when they do later courses and have to do math. You can think it much better. It's really a fun time too. So if you're interested, please let either me know or Miss Nyla Geraci on the Birmingham campus. And we had thought we'd start yesterday, but something came up. We will, with the student who was going to come. So I think on Monday, Wednesday afternoons from 3:15 to 4:45 or somewhere thereabout. We may not take that long. We'll start having practices. So if you want to come just to see what it's like, it'll be in this room Monday and Wednesday afternoon, 3:15 to 4:45. Come and see what it's like, see what kind of questions. And believe me, you'll be helping yourself out for the future. When you take some of these courses, you'll be, oh yeah, I know this stuff, and you'll be able to get a lot more out of it. All right. Any questions on anything we've done so far? All right. Now, am I on the right page? I think I must be. Yeah, I put my marker in the wrong place. Okay, we talked about average rate of change of a function. What was that very similar to? Say again? Okay, no, okay. Say again? Yeah, the difference quotient. Very similar to the difference. In fact, it's the same thing, basically. But now we're talking about a function that represents something and how much it's changing, whereas the difference quotient can be anything. But so here's what we have. Find the average rate of change of this function, okay, from x1, -2 to x2, -1. Okay? Now, they don't give us a whole lot of room here, so let's do what we can. What is how do we do a different average rate of change? Whoops. For some reason, my pen's not. There we go. All right, let's get it dark again. So how do we get average rate of change? How does that work? y2 minus y1 over x2 minus x1. Wait a minute, isn't that the slope formula? That's exactly the slope formula. It's the same thing you've been doing since algebra, okay? Simple algebra. You've been doing this for quite a while. What's your y2? What's another name for that? Alpha of x2. See, x2 refers to, okay, alpha of x2 minus, what's y1? Alpha of x1, you got it. And then, of course, we know what x2 and x1 are. Or we will fill them in a minute. So, the first thing we've got to do is alpha of x2. What's your x2? For the A part? -1. So, let's do alpha of -1. And what is that? -1 cubed minus 3 times -1. Okay, what's -1 cubed? -1. Okay, y'all stuck in it. Okay, and then what's minus 3 times -1? plus 3. So what does that equal? 2. Okay, so there's your first part, 2, minus, what's your f of x1? What is x1? x1. Negative 2 for the a part here. So we'll do f of negative 2. And what's that? Negative 2 cubed minus 3 times negative 2. What's negative 2 cubed? Second? Negative 8. Perfect. Negative 3 times negative 2 plus 6. And what's that equal to? Negative 2. So it's 2 minus a negative 2 divided by, what's your x2? Second? Negative 1 minus a negative 2. Okay, what's negative 2, what's 2 minus a minus 2? 4, very good. Divided by, what's negative 1 minus a minus 2? 1. Hey, guess what our average rate of change is? 4. Between these 2 points, the average rate of change is 4. See, here they did, at negative 2, we calculated the function to be negative 2. There it is. Okay? And at negative 1, where did we do it? There it is. At negative 1, we calculated the function to be 2. And there that is. And the line, we call it the secant line, between those 2 points is there. Very steep secant line with a slope or average rate of change of 4. 4 up, 1, 2, 3, 4 for every 1 to the right. Yep. Average rate of change was 4. Okay, how about let's do it from x1 equals 0 to x2 equal 1. You want to do this in a different color so we don't get as confused, or you want me to erase this and do it in a, what you want? Different color, okay? Because y'all are so special, you get to pick the color. What color you want? Say again? Green? You want the light or the dark? I can't hear.
Green is fine.
Green is fine. Light or dark? Dark? Okay, we'll go with dark. Okay? Now, we already got what it is. What is our y2 for the b part? Say again? F of y2. F of 1 minus f of 0 divided by 1 minus 0. Hey, I can do the denominator thing. Y'all don't have to worry about it, okay? Now, what's your f of 1? I think I will erase some here just so we'll have a little more room to write. Okay, what is our, f of 1? F of 1. 1 cubed. Okay, and what's 1 cubed? 1 minus 3, negative 2. All right, got that? So that'll be a minus 2 minus, and what's our f of 0? Oh boy, that's going to take a while. Say again? 0! Okay, 0 cubed minus 3 times 0 is 0. Okay, over 1. Now what that equal to? Negative 2. Everybody see that? What does that mean? From f of 0, which is, we just did it in our heads, 0, 0, 0, to f x2, which is 1, and f of 1 was minus 2. We did that up there. The slope of the line between that, we call that the secant line between those 2 points, is the average rate of change between here and there, x equal here to here, is the change of y here to here over that change of x. It shows us that's a slope of -2. Down 2 for every one to the right. Got it. Does that make sense? Yes.
If we know just do the slope, like actually just like you see from -1 and 2 to 0 and 0, we could just over 1 down 2. We could just do it like that.
Yeah.
So we ain't have to.
I was getting you to practice using the formula. Okay. Because they drew the graph for you. You lazy bum. Okay. If you want to draw the graph, then go for it. But if they didn't give you that, even if you didn't have the graph, you would have calculated it. And guess what? On the quiz or on the test, I'm not going to draw the graph for you. Okay? Okay, so you're going to have to do it. So you can do it either way you want to. If you want to draw the graph, get the lines, that kind of stuff, sure, you can do it. You're just being lazy because they did it for you. Huh? All right, I got it. Any questions? Good point. Yeah. It's just the slope of the secant line. And like you said, down to it, right to 1. Yeah. Any questions? Okay. By the way, there's a checkpoint. Okay. So always pay attention to those. Do them as soon as you can after class. Let's see. Okay, I'm sure they're going to do it. So let me clear this out of the way. Also, I'm going to go back to dark and erase all the ink, and let's see how they do it. Yeah, they do f of x2 minus f of x1 over x2 minus x1. Where did they get that? It's f of -1 for the first one, minus f of -2 over -1 minus -2. Wait a minute. What if they cross those up? What if they put f of x1 minus f of x2 over x1 minus x2? Would they have screwed it up? No. Because you reverse the sign here, but you reverse the sign there, you get the same answer. So it doesn't matter which one you name 1 and 2, but just make sure that whatever you have here, you have there. You know, the ordered pairs stay together. Okay? So, f of -1, they just came out of the air or some body part and said that is a +2. Maybe they cheated and looked at the graph too. Minus f of -2 was a -2 over 1. They did that pretty quickly, and that gave them 4 over 1, which is 4. The secant line has a positive slope, a pretty steep positive slope, and we saw that on the graph. For the B part, differ x1 and x2. F of x2 minus f of x1 over x2 minus x1. That's your average rate of change, always. Same as the difference quotient, isn't it? F of 1 minus f of 0 over 1 minus 0. I can do that denominator. That's a 1. The f of 1 is a -2. F of 0 was a 0. That gave us -2. That was a negative slope, not quite as steep as the former one was, but still pretty steep. Makes sense? Okay. Now they're skipping. Okay. They're skipping example 7. Let's do that one. That's a real life problem type thing. The distance S, measured in feet, okay, that's the distance measured in feet, of a moving car from a stoplight is given by this function. S as a function of t, which I'm going to guess is time, is equal to 20 times t to the 1/2 power. Okay, that's a pretty good guess. I'm not going to say it's exactly right, but it's a pretty good guess. Okay? This is example 7, bottom of page 54. Yeah. What's that? You're right, okay? My book changed the number on. No, I'm just kidding. I can't read, okay? 3 has power. Okay? Thank you. All right. Now, let's at least start with, does this even make sense? If it's from a stoplight at t equals 0, what should you be? You should be stopped. So your distance from the, yeah, that's what I said. I don't want you sliding through it, okay? All right. So if you're stopped at a stoplight at time t equals 0, What should be your distance from the light? 0, is it? Sure, well, that sort of makes sense for a little bit anyway. So let's go on, where t is the time in seconds. Find the average speed of the car, A, from t equals 0, t1 equals 0 to t2 equals 4. Okay, we'll do that in first and come back and do the second one. So how do we do this? We want the average speed of the car. Okay, S of T2 minus S of T1 sounds like a good way to go, divided by T2 minus T1. I thought that's what you said. Okay, very good. And what is S of T2? Oh boy, y'all are quick, aren't you? Did you say it again? Okay, T2 is 4. Okay, what is S of T2? S of 4 would be 20. And someone remind me, what in the world do we mean by something to the 3 has power? Okay, very good. What your numerator of an exponent tells you is the power to raise it to, just like normal. What the denominator in an exponent tells you is the index of your radical. Okay, so this would be the same as, I'll rewrite it this way, 20 times the square root of 4 cubed. Okay, now you could have done it the other way. You could have done it 4 cubed and then take the square root of that. Which you think is easier? This way. Keeps the numbers smaller. What is the square root of 4? I'm sorry? 2 and 20 and the cube and 2 cubed is 8. Okay? And 20 times 8 is what? 160. So that'd be 160 feet because S is measured in feet. Does everybody see that? Okay? I didn't write all the steps down there, but y'all said them right. Would it help for me to write them? Yay or nay? Huh? You okay? Everybody okay? All right. That's 160 feet. So that's my S of T2. 160 feet. Okay, minus, what's S of T1? 0, because it's 20 times 0 to the 3 has power. The square root of 0 is 0. 0 cubed is 0, and 20 times 0 is 0. So that's just 160 over, and what's your denominator? 4. 4 what? Seconds. Okay, we're thinking we're in physics class now, right? Units matter, okay? So, what is 100? That's what? 40 feet per second. You got it. There is your average speed between those two times. Okay? Now the B part says, you want this one, your green. What was your color before? I didn't understand. Red? Okay. Let me see if I can get the red to come up. Okay. You like seeing red on your paper, okay? All right. Where is the B part? T equal 4 seconds. No, T equal 4. T1 is 4 seconds. T2 is 9 seconds. Did they choose some nice numbers for us? Yes, they did, because you can take square roots of them pretty easily. What's your average speed between those two times? Okay, she's going right to the formula. 20 times 9 to the 3 has power minus 20 times 4 to the 3 has power divided by 9 minus 4. Okay? I'll probably be able to do the denominator by myself, but I need help with that numerator. Okay. What's this now? Square root of 9 is 3, and 3 cubed is 27. 20 times 27? 540. What units? Feet minus. Now I'm looking for a lazy person to help me out of here. Yeah, we already did F before. It's right up here, so we don't have to do it again. Knew there was a reason he was in the class, okay? Minus 160 feet, right? Be lazy, okay. Divided by 5, okay. I was going to do that. Okay, and what does that equal to? A little louder. Did you say 380? I couldn't hear. Oh, you've already done the math. Goodness gracious, he's fast. 380, right? Divided by 5, which is 76, you say? Yeah. 76 what? Feet per second. Got it. So that next 5-second period, the average rate of change was much faster than the first one. Why? The first one, you're starting off at 0 and building up speed slowly. After that, you're building it up fast. You better watch it because after a while, you're going to be breaking the speed limit. Okay, so watch that. Okay. Average rate of speed, 76 feet per second. Let's see how the book did. Oh, look at that. They got them right. Good for them. Okay, any questions on that? They have a checkpoint there. If that was a little fuzzy or we went too fast, check out the checkpoint. And if you can't get it, there's an audio-video solution in LarsonPrecalculus.com. Free website. Use it. Go for it. All right. Any questions? All right. Let's go to the next topic as soon as I get this thing. Even and odd functions. Okay? Now, I know y'all are probably familiar with a lot of pretty odd functions, right? But no, okay. Even functions you may not be as familiar with. No, that's not what we're talking about. What do we mean, even and odd functions? Anyone have an idea? We'll see. Let's see. What's that? Okay, yeah. You compare what's happening on both sides of the y-axis, by the way. You have studied different types of symmetry in a graph. They assume you have anyway. I guess that was from earlier in the chapter, 1.3 to 1.1 to 1.3. But in the terminology of functions, a function is said to be even when the graph is symmetric with respect to the y-axis. Whatever it's doing when you do a positive x, it does the same thing when you do a negative x. It's said to be odd, not when it's a strange-looking function, but it's when it's symmetric with respect to origin. That means whatever it's doing to the right, with a positive x, it does the opposite of it for a negative x. That means it's symmetric about the origin. Okay? The symmetry test yields the following test for even and odd functions. Now, guess what we did on both cases? We knew what it was doing on the right when x was positive. Our test is, what happens when x is negative? Right? If it's the same thing, it's even. If it's the opposite from it, it's odd. They left off one here. If it's neither the same or opposite, it's a neither function. Hint, most functions are neither functions. Okay? Depending on what type of function you're looking at. When you get in the trig, they're all either even or odd. There aren't any neithers most of the time there. Okay. So the symmetry test yields the following test. That's sort of redundant, isn't it? For even and odd functions. Test for even and odd functions. A function y is equal to f of x is even when, for each x in the domain of f of negative x is exactly the same as f of positive x. That means whatever you're doing on the right, you do the same thing to the left. Same thing, identically the same thing. It's odd if when, for each x in the domain of f, when you get f of negative x, you wind up being the opposite of f of x. If f of x is down here, it's up here. Okay? Now guess what? the test is the same. Whatever your function is, plug in a minus x rather than x. And when you do that, see what your answer is. If it came out being the same as what you had for f of x, even function. If it came out exactly the opposite of what you had for f of x, it's an odd function. If it came out neither the same or opposite, it's a neither function. Okay? They didn't tell you about neithers. Okay. Now they are doing most of the work for you. Shame on them. Okay? Now, they even tell you what the answer is. Here's your function. G of x is equal to x cubed minus x. Okay? What's your test? Plug in a minus x here. What's g of minus x? Don't look there. Okay? It's like saying, don't think of a big black horse. Okay? You get off of the red here and go back to black, or dark anyway. G of minus x would be what? Minus x cubed minus a minus x. Very good. And what's minus x cubed? Minus x cubed. You're sort of redundant. Okay. And what's minus a minus x? Plus x. Okay. There's what g of minus x is. And look at that. That's exactly the opposite of g of x, isn't it? Exactly. Where x, the first term is positive, this one's negative. Where that one's negative, this one's positive. Exactly the opposite. That's an odd function. Okay? That's what we do. Why they gave you the answer and then showed you how to do it and didn't let you do it yourself, shame on them. Okay. All right. And I think they'll do the same with, and that's equal to negative x cubed plus x. And that is exactly the opposite of g of x, x cubed minus x, meaning that passed the test for an odd function. Boy, they strung that out, didn't they? All right, and we'll do the same thing here. What's your test? Say again? Put a negative x in there. And what happens? Negative x squared plus 1. And what's negative x squared? X squared plus 1. Guess what? Same thing as h of x. H of negative x is the same thing as h of x. That means it's an even function. Exactly. And they show you how to do it here. And you get that, which we got. That's the same as h of x. So therefore, now, let's look at the graphs of those two functions. Let's see if they make sense. Here's that g of x, which is x cubed minus x. They graphed it for you. You'll have to do this yourself, okay? There is the graph of it, and guess what? Whatever is happening on the right, exactly the opposite is happening on the left. Okay? Exactly the opposite. This goes down, that goes up. By the same amount, then this goes up, this is going down. Exactly symmetric about the origin. Therefore, that is the odd function. Okay? This one, however, h squared plus 1, if you graph it, that's what you get. And when you do an x in here, you get this. When you do a minus x, you get the same y value every time. For every x in here, you get the same. That's an even function. And that's what your test was doing. Now, boy, if this graph here were shifted over here just a little, or down here a little, or up, or anywhere else, neither. If this was shifted down or up, it's still even. But if you shift it over here, neither. Okay. So yeah, it's pretty easy to get a neither function. Almost hard to get an even or odd, but they did. Now, I know you don't want me to show you something that makes it a little easier, do you? What's that? I can't hear you. Okay. Let's go back. I thought they were going to show it all at the same time, but let's do, okay. Let's just do this. Now, what I'm about to show you works for polynomial functions. I don't want to say only polynomial functions, but it does work for polynomial functions. Okay? Look at my exponents in that function. Polynomial function has a variable with exponents, right? What are my exponents here? 3 and 1. Guess what kind of numbers those are? Odd. Is this an odd? Oh, isn't that clever? Okay. Now look at this one. What's our exponents here? 2 and 0. X to the 0th power is 1. Okay? And what are 2 and 0? Even. Now, could that be the case? Yeah, it is the case. It's a lot easier than plugging in. But not all functions are polynomial functions. So it's not a polynomial function, plug. Okay? If it is one, still plug. Okay. Any questions on that? Sorry, I shouldn't have shown you something so simple. All right. There is a checkpoint there. And guess what? You're going to run into at least one neither function there. So do your checkpoint. All right. Any questions? 1.5. Let's hit vocabulary. Top of page 56. The blank, blank, blank is used to determine whether a graph represents y as a function of x. Vertical line test. Excellent. Number 2. The blank of a function, y is equal f of x, are the values of x for which f of x equals 0. The zeros of a function. You're absolutely right. Number 3. A function f is blank on an interval when, for every x1 and x2 in the interval, and x1 is less than x2, that implies that f of x1 is greater than f of x2. What is that function? Nope. Decreasing function. Okay, decreasing function. Everybody see that? Number 4, because it said that f of x1, which is over here, is greater than f of x2 there. For every one in there, that means it's a decreasing function. Okay. Number 4, a function value f of a is a relative blank of f when there exists on an interval x1 and x2 containing a such that x1 is less than x is less than x2. That implies that f of a is always greater than or equal to any of the other f of x's there. I don't think so. F of a is greater than or equal to f of a. Maximum. A relative maximum. Okay, they just say, yeah, they had relative, you put maximum. Did everybody see that? Number 5. The blank, 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 blank between 2 points, x1 f of x1 and x2 f of x2, is the slope of the line through the 2 points. Average rate of change of the function, you got it, and that line is called the blank line. Secant line, you got it. Number 6, a function f is blank when, for every x in the domain of f of minus x is equal to minus f of x. Yeah, odd. Okay, got it. All right, homework exercises here. Do either 7 or 9 or both. And let me get your name, please. Second? Josh, right. Okay, let me find you. There you are. Jones, right. Okay. Do either 7 or 9. Both of those answers are in calccheck.com, but number 9 is in calcview.com. Okay? Then do either 11 or 13 or both. 11's in CalcView. They're both in CalcChat. Okay? Do any of the odd number exercises 15 to 25. And 25's in CalcView. All of those odds are in CalcChat. Okay? Do any of the odds 27 to 31. All of those are in CalcChat. None of them are in CalcView. Then do any of the odds 33 through 39. All of those odds are in CalcChat, but 35 is in CalcView. Then do any of the odds 41 to 47. They're all in CalcChat, but none of them in CalcView. Then do any of the odds 49 to 53. All of them are in CalcChat, but only 51 is in CalcView. and do any of the odds 55 to 59. They're all three in Calc Chat, but 5.57 is in Calc View. And then average rate of change, either 61 or 63. 61's in Calc View, both of them are in Calc Chat. And then any of the odds 65 through, well, let's do 65, okay? Do 65. Then do either 67 or 69. By the way, none of those are in Calc View, but all the odds are in Calc Chat. Then, even an odd or neither functions, they threw in the neither here, any of the odds 71 through 75, 71's in Calc View. And then more even odd or neither, and not, okay. And by the way, some of those are polynomial and some are not in both groups here. Do either any of the odds 77 to 81. None of them are in Calc View. Do number 83. Do number 85. And then you can choose either 87 or 89. Now, when you see these with the big X's on them, that means what they've written here is an error. You got to find where the error is. I kind of don't like that because I don't like writing anything that's wrong. You know, because you get used to seeing wrong stuff. I want you to see right stuff. Okay, that's why I want you to do all your answers right. Okay, I'm sorry. Yeah. So either 87 or 89. Neither of them are in Calc View, but they're in Calc Chat. And then on the exploration, these are sort of up to you. Don't expect to see many things like true false. I don't usually ask those on tests or quizzes, but 91 or 90. I don't know if the answers are in the back. I would do them all and see if you understand what they're talking about, but 91 and 93 may be in the back. Think about it is 95, only if you choose to. The writing, that's up to you. 97, some more even, odd or neithers at 99. So if you want to do those, but anything beyond the exploration or in the exploration, you choose whether you want to do it. Okay, any questions on 1.5? Okay. Let's move on to 1.6. And when we finish 1.6, I will give you the quiz. Okay? And I'll probably have it ready, try to have it ready on Tuesday morning. So whether we finish it or not, you'll have a little extra time to do it. Okay? If the 1.6 will ever open. There it comes. We have to sit through this again. Any questions so far? Okay. The quizzes are all take home. Okay? And so you get to take it home, work it at your leisure. Try to get it back to me within a week. Now, the reason I give you a week, two reasons actually. One, you always have one more day to ask a question. You know, if you don't understand something about it, or something like that. The second reason, you always have a weekend to work on it. Okay? So try to have it back within a week. Now, I'm not super hard and fast on that. You can have more time if you need it. I want you to do well on the quizzes, get the take on this stuff. But you've got to turn it in before test time. I want you to turn it in well before that because I can't return anyone else's quiz until I get them all in. So please get them in as soon as you can. Okay. Now, did you also say what did they count? No. Oh, okay. Yeah, they're completely done at home. The tests, on the other hand, are done in class. Now, let me say this again. I think I said it earlier, but just in case you may have forgotten. For your test, every test we take, including the final, you can have a formula and equation sheet. Anything you want to write down on a piece of paper, you can have with you during the test. It's in class, closed book, but you can have that piece of paper. Okay? Now, there's two reasons I do that. One is the obvious one, so you don't panic and go blank on something. You have a chance to have it in front of you, okay? Because people claim, I just have it, whatever. But the second thing, it's a great practice to do. Very seldom when I was an undergraduate did I have a professor who let us have a formula equation sheet. But on those rare occasions it did, man, I sat down and wrote down everything I could think of, and wrote down as small as I could read, but I wanted to try to organize it and did all that, try to pick out the important things and doing all that, getting all on the piece of paper and so on. And then when I went to take the test, I almost forgot to look at it because I found out if I did that the night before, it was the best study technique I had ever run into in my life. So I would suggest every test you ever take, do a formula and equation sheet. Now, if the instructor or professor doesn't allow you to have it in class, don't bring it into class, but do it because it's the best study technique I know of. Okay? So I want you to get into the habit of doing that. Hopefully you'll see results from it. Okay. That was my commercial. Let's get on to the 1.6. Still talking about functions and their graphs. We've done graphing, but been talking largely about the functions. This section is a library of parent functions. That's where functions send their parents. They go to the library so they can play. No, I'm just kidding. Okay, what do we mean by this? We're going to identify and graph linear and squaring functions. Those are pretty simple. Identify and graph cubic, square root, and reciprocal functions. A little more involved there. We'll identify and graph step and other piecewise defined functions. And we'll try to recognize graphs of parent functions. Okay? So let's start with the simplest ones, linear and squaring functions. What do you think a linear function graph might look like? A line, yeah, that's why they call it linear. It's all line. And then the squaring functions, we're going to give a name to that too. But we're going to do the simple ones, okay? One of the goals of this text is to enable you to recognize the basic shapes of the graphs of different types of functions. Not just when they're graphed, but even when they're written as an equation. So you should look at that and say, oh, that's going to be a linear function. Or, oh, it's going to be we'll call it later, a quadratic function or parabola, and we'll have different names for it, okay? For instance, you know that the graph of a linear function, and here's the simplest, or the most general case of how you do a linear function. Alpha of x is equal to ax plus b. Does that sound vaguely familiar? Wow. What does that sound like? And how does that one go? It didn't sound quite like this. Y is equal to mx plus b. Why do we call that? That's the slope. And what do we call b? The y-intercept. Guess what? Guess what alpha of x is? Y. This is the same as your slope-intercept form. Remember, we had lots of different ways we could write a linear equation. The simplest one, the one that gave you the most information, was slope-intercept form. Guess what? That's the one we always use with functions. Alpha of x, y is equal to ax plus b. Now, a is the slope, b is the y-intercept. Okay, and that's what it says. Slope m equal a, y-intercept at 0b. B isn't y-intercept. The point 0b is the y-intercept. Okay, nitpicky. Okay, and you should see that anyway. Put a 0 in for x, and what do you have? Y is equal to b. Yeah, 0b is the y-intercept. That's where it crosses the y-axis. Okay, now, they're going to tell you some of the features of the graph, and they're going to show you the graph. The graph of linear function has the following characteristics. What do you reckon the domain of the graph is? Yes, all real numbers, negative infinity to positive infinity, all real numbers. Okay, there's only one line that's not true for. A vertical line. Vertical line does not go from negative infinity to positive infinity. It's only defined at one value of x, whatever that is. And by the way, we named that line x equals 8 or something like that. Now, why is that not included in our function here? It's not a function. Why isn't it a function? It fails something. The vertical line test, because most vertical lines never intercept it, but the one that does intercept it has more than one point. In fact, it has all the points on it. So yeah, the vertical line is not counted as a linear function because it's a vertical line test. So all others, no matter how steep they are, the axis goes from negative infinity to positive infinity. How about the range? Negative infinity to positive infinity as well, except for one other kind of function. A horizontal function. A horizontal function, what's its range? It's just one value. Let's call it d, okay? Y equals d, okay? And it's the only element in its domain. Okay, so when m is not equal to 0, because if m is equal to 0, what does m stand for, by the way? The slope. And if m is equal to 0, what kind of line is that? Horizontal. So that's the one today. So if m is not equal to 0, slightly positive, slightly negative, very positive, very negative, the range of the function is all real numbers. Negative infinity, positive infinity. Okay, the graph of every linear function has a y-intercept. Now they throw in, it has an x-intercept. We know what the y-intercept is, 0d. Now, did you know that was the x-intercept? Sure you did, whether you realize it or not. What was the linear function? Give me again the equation for a linear function. Y is equal to mx plus b. Now that's an equation of a line. Really, the function would be f of x. Okay, but let's stay with that because this is actually handier. Now, what was true about the y-intercept? Every y-intercept. What's true about a y-intercept? X equals 0. And we've already done that. When x equals 0, y is equal to b, there's your x-intercept. 0 for x, b for y. So what's true about every x-intercept? Y is equal to 0. You got it. So let's do that. 0 is equal to mx plus b. Now I want to know what x goes with that. So what would we do? What would we do? Yeah, we already plugged in 0 for y. No, not plug in. Solve for x. Okay? How do you solve for x? Subtract b from both sides. Okay? That goes away, and you get mx is equal to negative b. And we still want to solve for x, so we do what? Divide by m. Divide by, and remember we said m is not equal to 0, right? If your m was 0, we don't do that, do we? Because you can't divide by 0, so don't ever divide by 0. But as long as m is not 0, you can do this, and that's legal in most states. Okay? And what do you have? X equal negative b over m. There you have it. You knew how to get that. Do I ever sit down and say, oh, let's see, my x-intercept? No, I just plug in a 0 and see what the y is, the x value is. 0 for y. I don't go through all that. But that's what it is, always. Okay? The graph is, how can you tell if a linear function is increasing? Say again? The line goes up, okay, but what if all you have is the equation? You don't have the graph yet. What? Look at the sign of the slope. If the slope is positive, it's going up. If it's negative, it's going down. If it's 0, it's horizontal. Right? Look at the slope. The graph is increasing when m is greater than 0, decreasing when m is negative or less than 0, constant when m is equal to 0. You know all this already. Right? So those are characteristics of a linear function. We haven't even gotten to the squaring function yet. Okay? So let's write the linear function for which f of 1 is equal to 3 and f of 4 is equal to 0. How can we write that? They just give us 2 values for f. Say again? They gave you y and x, so what can you do with them? Okay, he loves that, doesn't he? Okay, what does that give you? y2 minus y1 over x2 minus x1. We have all those, don't we? What does that give you? M, there's your slope. So plug it in, plug it in. What do you get? Say again? 0 minus 3. Say again? 4 minus 1. And what does that give you? Negative 3 over 3, which is negative 1. Okay, I got the slope. Okay, a little louder. Okay. Okay. I'm going to show you a little trick. And you probably are doing this in your head. But okay, you could, but I don't want to. I'm way too lazy for that. Okay. Let's take that same formula you just had. And I'm going to multiply both sides by that denominator because I don't like denominators that much. I mean, I know you like fractions. I mean, I could live without them. So I'm going to rewrite that as y2 minus y1 is equal to m times x2 minus x1. Is that true? Oh, look at that. He gave a name for it. Okay? And all I'm going to do here is erase my 2's. Right? And that gives you, what do we call that? The point slope formula. All you need is 1 point and a slope. And guess what? We got 2 points and a slope, so we can sure use this. Pick a point. I don't care which one. Don't we have 2 points? What are my 2 points? Points are ordered pairs. What are your 2 points? 1, 3, or 4, 0. You get to choose which one you like. So y minus, which one? 3. Okay, if you choose that, then you're limited on the next one, is equal to negative 1 times x is the variable. Don't do anything with that. Minus 1. You got it. Okay? Now, what do we have? Let's clear the parentheses first. Y minus 3 is equal to negative x plus 1. Add 3 to both sides, right? Y is equal to minus x plus 4. But it said write the linear function, f. I don't see any f's in there. Oh, what is y? F of x. F of x is equal to minus x plus 4. There you did it. And it wasn't that bad, was it? Okay? Now, I'm not sure they're going to do the same thing, but let's do a timeout here. I didn't like that he chose this to be his y1. I wanted 3 to be my y2. Okay? Would everything have changed? No. This would have been 3 minus 0, which is 3, and this would be 1 minus 4, which is negative 3, and that would have been 3 over negative 3, which is still minus 1. So it didn't matter which one you chose being F1, X2. But once you choose one, the others are fixed. You can't say, oh, well, I want this to be X1, but I want this to be Y1. No, you got to stick with it. And then once you do this, did it matter what point you used? No, it didn't. If you'd have used 4, 0, then this would have been 4 here and a 0 here, and that would have been y is equal to minus x plus 4. Goodness, that would have been easier, wouldn't it? Yeah, but you get the same answer either way. You don't have to be super lazy. You can work hard. It still works. Okay. Everybody see that? All right, good deal. So we just wrote the linear function. Let's see how they write the linear function. Okay? To find the equation of a line that passes through 2 points, first find the slope. Hey, that's what we did. Okay? We even use the same formula. Okay? And they even choose the same points. Okay? And that gave them a negative 3 over 3, which is minus 1. And then they went to the point slope formula, but they pulled it out of their head or somewhere else, and we figured out what it was. Okay? There's your point slope formula. And then all you do is plug in. And they chose the same point you did. They like to work hard too, okay? And when you did the work, solve for y. Why do you solve for y? because you want an f of x. That's exactly it. So there's your y, but you want f of x is equal to minus x plus 4. Make sense? All right, good deal. And here's the graph of it. And what were the 2 points they said were on the line? 1, 3, and, or was it 4, 0? I think it was 4, 0. Yeah. And sure enough, those two are on the line. And then you can look at this and say, hey, my y-intercept is 0, 4, and the slope is minus 1. Down 1 for every 1 over down 1 for every 1 to the right. Yeah, definitely. Make sense? All right, good deal. All right, two really special kinds of linear functions. We've already hinted at them, or one of them anyway. One is a constant function. What's true about a constant function? Slope is 0, so m is 0, so there is no x term in it. The coefficient for x is 0, so you just have y is equal to, and why they said c, why not b? That's what we used before, but c is fine, it's just as good as anything. And whatever that c is, y is always that. And with a constant function, what changes from what if that m was not 0? Domain's the same, all real numbers. But the range is now one value, whereas a normal linear function is all real numbers. Okay. So that's the only thing that changes here. So m is 0. That's not much of an equation, but that is the equation of a constant function. Alpha of x equals c or b or whatever you want it to be. Okay? Just a constant. Now the second of these is the identity function. And that's alpha of x equals x. Now what does alpha of x stand for? Y. So name me an ordered pair on that line. 1, 1, 2, 2, negative 7, negative 7, 3, 3, negative 18 pi, negative 18 pi. I mean, whatever you have for x is the same value for y. So how do you reckon that's going to look? You left off one really simple point on that line. 0, 0 is on the line, so it goes through the origin. Okay? And forever that would be 1, 1, 2, 2. It will be the diagonal line splitting exactly the first and the third quadrants. Exactly. You got it. So there is, and what's the domain of that function? All real numbers. The range of that function? All real numbers. Okay? What's the slope? 1. What's the y-intercept? 0, 0. It's an ordered pair. 0, 0. Of course. Because it passes through the origin. M is 1 and B is 0. Okay, yeah, so slope and y-intercept. The graph is just the line for which the x-coordinate equals the corresponding y-coordinate. Positive or negative, they're always the same. It's always an increasing function. How do you know it was always an increasing function? Slope is positive, 1. You're absolutely right. How about that constant function? Increasing, decreasing? No, it's constant. That's why they call it a constant function. Neither increasing nor decreasing. Okay. Now let's move to the squaring function. Okay? This is the simplest squaring function. And by the way, that's what we, yes, huh? Oh, okay. That's what we call it the parent functions. Parents are really simple. No, I'm sorry. Okay? They are where all others come from. Okay? Now, I don't really like they call it a U-shaped curve. I know what they're meaning there. They're meaning at the bottom it's rounded. But a U goes straight up. This doesn't. It always goes out. So actually the name of that is it's a quadratic function. Parabola. The name of that shape is actually a parabola, which kind of is U-ish shaped a little bit. It's shaped like a U in that it's rounded at the bottom, but it's shaped sort of like a V because it gets wider apart at the top. But it's like neither one of them. Okay. Okay. Guess what the domain is for this function right here? Negative infinity, positive infinity. Any x you want to put in there, you can square. What's the range of that function? 0 to positive infinity. You cannot get a negative number out of that. You put in any real number there, you're always going to come out non-negative. Put in a 0, you get 0. That's neither negative or positive. Put in any negative number, it comes out positive. Put in a positive number, it comes out positive. So your range is 0 to positive infinity. Okay? Now, how about the evenness or oddness? It's what? It's an even function. It's absolutely right. You know, we didn't say that, did we, about the constant function? What about a constant function? It's what? Even. Whatever it is on the right, it's on the left, it's always the same. Okay? It's an even function. Okay? How about the identity function? That's odd because whatever it is on the right, it's the opposite of whatever it is on the left. Very good. Okay? And this one is even. Now, does it have an intercept? Which is it? What is it? 0, 0. How about your constant function? Does that have an intercept? What is it? It has a y-intercept, which is 0d, 0c, whatever that constant is. Does it have an x-intercept? No, it doesn't. Unless it tells an x equals 0, and then every number is an x-intercept. Okay, not very fair. And this one has both the x and y-intercept at 0, 0. And I think, unfortunately, we're out of time. Oh, how sad. Okay. Sorry, we're going to pick up kind of in the middle of this. We're going to be the squaring function. We're going to pick up with this decreasing, increasing type characteristic. Okay? Let's see if I can find some homework exercises. We didn't get very much done in this section. Yeah, you can do any of the odds, 11, either 11 or 13 or both. 11 being on Calc View and both of them being in Calc Chat. And you can do 15. And I would stop there. We'll do the rest of those later. Okay? So 11 and or 13 and 15. Good deal. Have a good weekend. Guess what then, folks? We're hoping to have class on Tuesday next week. Okay? All right. All right. Good deal. What's that?
Spent so much time telling us not to come to class Tuesday, but
yeah, and then was I right not to come to class Tuesday? Everybody listened to me, didn't they? Not just you. Okay. Yeah, that wasn't very good, was it? Okay, Walter never came in. Ebony, I don't think ever came in. Chelsea didn't come in. Okay, do you have a question?
Yeah. So, how much